Welcome to the day 8 notes. I'm going to have you work on this warm-up question, but before you pause the video and it says label all of the interior angles, I want you to list every angle that could be classified as an interior angle. There are quite a few of them. All right, so pause the video, see if you can come up with all of the interior angles, unpause, and see how you did. So for these, I'm going to start off by looking at these two lines, and then I'm going to pick a transversal. So I'm going to start with that transversal. So my interior angles for that group would be angle ABH. I can't use one letter because there's going to be multiple angle B's. So ABH is an interior. Angle EBH is an interior. And remember, these names can be a little bit different. Instead of EBH, I could have said angle FBH. It would have been the same thing. Or EBI would have been the same thing. Then I also have angle GHB and angle KHB. I like to personally pick the letters that are closest to that vertex to make my life a little bit easier. So that's the first 4. Now, I'm also going to look at this transversal next. So that would be angle BEK, angle FEK, angle HKE, and angle LKE. There's that next 4. So that's all of the interior angles if I'm looking at just these 2 red lines, and then having one of the others be a transversal. Now if I look at these 2 lines, I do the same process. I'll start with this transversal. I could have angle IHK, angle KHB. Okay, angle HKE, and angle HKJ would work. Now I'm going to switch to have that transversal. I would have angle CBF, or CBE would also work. Angle HBF, angle DEB, and angle BEK. So those are all the interior, so between those 2 green lines. Now I listed a whole bunch. You should double check to see if you duplicated any, because there will be some duplicates, like angle BEK. I definitely duplicated. BEK was interior between these 2, and it was interior between the greens. So kind of go back and double check, and I crossed off both. I should only really cross off one, and you should be able to look quickly based off of just that middle letter. So HBF and CBF, the only 2 B ones I had over here were these 2, and this is where if I would have picked a better letters, if I would put an E here instead of an F, that would have been easier to see that I copied that one. And then I can look at the H's, GHB and KHB. GHB, KHB are different, but KHB is the same as KHB, so I cross that one off. And I go through that process, but if I think about my interior angles for my red ones, they are right here. So those, and then I'm not going to say that these are congruent. I'm just kind of identifying, hey, these are angles that are interior for the red ones, and then the same idea for green. I would just add it in this angle, which in that case those ones are congruent. That one, and those. So I should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that means I still have one more duplicate that I could find. I'll let you go through and find that last duplicate. So today we're going to be talking about proofs. So there's a process involved in formulating a proof. Step number 1 is always the given information. What are you given? Your reasoning is given. Step number 2, when in doubt, use definition of the vocab term. Okay, if you have a vocab term in the given information, use it. These things are congruent. What does that mean? These things are supplementary. What does that mean? Step 3 is going to be look at or draw a picture. Sometimes you're going to be given a picture, sometimes you won't be. You got to be able to visualize what's happening. Another easy thing to find is vertical angles. So in that picture, look for vertical angles. Okay, we know vertical angles are congruent, so that's why I wrote congruent accidentally. So if you can find vertical angles, you can know they're congruent, and then you can use another definition of a vocab. And we want to look for linear pairs. If we know two things are a linear pair, we know that their measurements add up to 180 degrees. And overall, the last important part is know what you're trying to do, so know where you're going. So if I'm trying to prove two angles are congruent, I'm not going to be trying to mess around with segment, like I don't need a segment addition to figure out angles are congruent. So make sure you're thinking of relevant things. If you're looking at line segments, make sure you're using your line segment type theorems. If you're looking at angles, make sure you use your angle type theorems. So when do we need to know how to use, or when do we use the angle postulates and theorems, and when do we use their converses? So if I'm looking at a postulate or a theorem, I abbreviate theorem as THM. Okay, those are always if parallel, then the angles are blank. I'm saying blank because the corresponding angles would be congruent. The same side angles would be supplementary. The alternate interior, alternate exterior would be congruent. You have one thing that could be supplementary instead of congruent. So this is usually the case if we are given that lines are parallel. We use these to prove angles are, again, blank. These blanks are either congruent or supplementary, depending on which theorem. And then the converses, we use them in the exact reverse. So if the angles are blank, then we have parallel lines. So I'm just going to use blue arrow to throw this in that blank. I think I might have said blue, meant green. So again, converses are used if we are given angles are congruent. Or if they're supplementary, if they're the same side interior angles. We want to prove lines are parallel. Again, put that piece in right there. That's how you want to be able to identify which things are which. If you write out if parallel, then angles are congruent, or if angles are congruent, then the lines are parallel, that's going to be a little bit easier than trying to remember necessarily what the difference between a postulate theorem and a converse is. So for this one, we want to prove that line M is parallel to line N. Step one is our given information. I can mark that in my picture to help me out a little bit. Now, step two, if I don't know what to do, is to say, hey, I've got two things that are congruent, so their measurements are equal. That's the definition of congruent. Okay, I'm going to go through this proof like I'm not really sure what I'm supposed to do. I'm just going to kind of blindly follow that process. All right, well, I don't really know what to do now, but I can look for vertical angles. I know what vertical angles look like. So step 3, I could say that angle 5 is congruent to angle 8, or I could say angle 1 is congruent to angle 4 because vertical angles are congruent. Maybe I don't need that. Or you think, oh, I've got those things, I want to prove something's parallel, I can use those converses. I've got a few different things I could use now. Okay, I know those are congruent like that. I could say, hey, M is parallel to N because if corresponding angles are congruent, then we have parallel lines. That's perfectly true. And we actually did not need step 2 or step 3 because angle 1 and angle 5 are corresponding angles. If you put in step 2 and step 3, I'm not going to mark it wrong. I'll cross them off because they're unnecessary, but they are accurate pieces of information. I'm not going to mark you something wrong for being right. It's unnecessary, but it's still correct. So I could have done this proof in 2 steps. For this next one, we want to prove that line M is parallel to line N. So again, start statements, reasons. Step 1, we're given measurement of angle 2 plus measurement of angle 8 equals 180. That is given to us. So I'm going to say, hey, I know these 2 angles. I don't have any vocab terms in the given, so I can't really do that. But step 2, I'm going to look for vertical angles. I could say angle 2 is congruent to angle 3, and angle 5 is congruent to angle 8, because vertical angles are congruent. And I picked those angles specifically because they're vertical angles with angles that I know some information about. I know angle 2 and angle 8. When I add their measurements together, I get 180. So I don't know if these are congruent yet, so I can't say 1 mark, 1 mark, 1 mark, 1 mark. I need to separate them a little bit. But step 3, now I've got a vocab term. The measurement of angle 2 equals the measurement of angle 3. Measurement of angle 5 equals the measurement of angle 8. That's our definition of congruent. Going from congruent to equals. Now, if I've got those things are congruent, and I know that, hey, I had this thing all along, I now know the measurement of angle 2 is that, measurement of angle 8 is that, I can say measurement of angle 3 plus measurement of angle 5 equals 180. And I did that by substituting. All right, if I substitute those things, the super technical way of doing this is saying, hey, those 2 angles add up to 180, so that means they are supplementary. Angle 3 and angle 5 are supplementary by the definition of supplementary. This is one of those steps where it's like, oh, you know what it means. Technically, you should write it down. I'm not going to be as picky about that as I am other steps. But if I've got that same side interior angles are supplementary, that tells me that I know these lines are parallel. Okay, if same side interior angles are supplementary, then the lines are parallel. Since this is exactly how this is written, if same side interior angles are supplementary, I need to have the word supplementary in my proof somewhere. But that you just need to know that supplementary means you add up to 180. So for this one, it's a little bit easier. We're solving for x. Find values of x that make the lines M and N parallel. First, identify that these are alternate exterior angles. If alternate exterior angles are congruent, meaning if their measurements are the same, those lines are going to be parallel. Minus 12x from both sides. We've got x equals 10. Plug it in just to double check. This would have been 140 degrees. Sounds pretty easy. 12 times 10 is 120. Plus 20 is 140 degrees. So x equals 10 would make lines M and N parallel. So what did we go over in this lesson today? What things are you not so sure on? What things might you need practice for, more practice with? Here's where you can write that down. Hope everybody has a great day.